Hello, pre-calculus. We'll be doing some more practice with vectors today. First, I wanted to give you a chance to check your answers from yesterday. I know there were some challenging word problems on there, but let's see how you did. We had some young ladies come in at the end of the day during period 8 yesterday, and we went over number, 102 together. So you'll actually find sort of a nice worked out solution to number 102 on Schoology. If you'd like to take a better look at that, you can go on Schoology. It's under the notes section. We can also go over these more tomorrow. I won't count it late. If you want to postpone handing this in, I'm okay with that. But go ahead and pause now and check the ones that you can see on the screen right now. Number 93 was an interesting one where they gave you the resultant force of 6,000 and you had to sort of backtrack to find those initial vector magnitudes. And then we had these. You can pause again. And I guess the one thing on number 102 I should point out is that when it says the bearing of the angle, the bearing for a plane is just measured from north and goes clockwise. So when it said that that plane was traveling at a bearing of 332 degrees, that's what made us know that that plane was heading in the direction of the second quadrant for us. Again, we can talk about this more tomorrow. Let's get on with the worksheet. So we know our word problems so far are basically just adding two vectors together. So I wanted to review the geometric way that we look at that when we add a vector v and a vector u together. By the way, sometimes they'll just have them bold and they won't have the little arrows over the top of them. That's just sort of something they do when they print it in a book sometimes. So vector v and vector u, if we wanted to add those together, we would just do our best to draw a nice parallelogram. Just do your best. And then our resultant vector would take this initial point here and connect out to that terminal point being the diagonal of our parallelogram. One thing I did want to point out is that this 20-degree angle down here is not cut into a 10 and a 10. It is not bisected. Because that u vector was a longer vector, it actually skews more towards the u vector. Number 2, same idea. If we're adding u plus v together, we're going to want to try to make a parallelogram. Just do your best. This time you'll notice that our resultant vector, again, it doesn't split that angle perfectly, but do you see how the resultant vector is shorter than either of the other two? And that's because those forces were kind of pulling against each other, so they almost canceled some of each other out. So that resultant force, or resultant speed, or whatever it is, that magnitude is smaller than the original two. One more. Adding two vectors together. And again, I keep using the parallelogram method. I could also think about taking vector u and putting it up here. Then I'm ignoring vector u. And then u plus v would be the vector that connects the original tail to the final head. That's the head to tail method. But really, as somebody pointed out, that's really just the parallelogram method without that line drawn. All right. Vector u has a magnitude of 20, so this must be vector u, and a direction of 0 degrees. That's nice. Vector v is the other one, has a magnitude of 40 and a direction of 60 degrees. That's measured in our usual way. And we're going to find the magnitude and direction of the resultant to the nearest whole number. The resultant just means that we are going to add the two vectors together. So step one of adding two vectors together is figuring out what the component form is for those two vectors, yeah? So to me, vector u is the easy one. Since it's pointing directly to the right, that would be 20, 0. Vector v is going to take a little more work because we have to figure out what its x and its y coordinate would be. Well, can you see that 60-degree angle in there with a hypotenuse of 40? So we're thinking cosine of 60 would give me the x value. And then the sine would give me the y value. And so the x would just be 40 times cosine 60. I think we're getting 20. And the sine would be 40 times sine of 60, which is 20 times the square root of 3. Because I know a little something about 30, 60, 90 triangles. But you can also get the decimal version of that too. Anyway, once we get that, we can write what vector v is. I'm going to clean this up a little bit. All right, now that we have vector v and vector u, it's time to find that resultant vector. And the resultant vector is where we just add u plus v together. Let's do it. U plus v would be the 20 plus 20, and the 34 plus 0, and that would be our resultant vector. Didn't actually ask for the resultant vector, it asked for the magnitude and the direction of that. So let's first find the magnitude of that one. Magnitude is represented with those double bars. So we're just going to take 40 squared plus the 34 number squared, take the square root of that. Set to the nearest whole number. So I'm going to say that is, 53. And I don't know if that magnitude is representing miles per hour or newtons or pounds or what it was this time, but that is the magnitude. And then we can kind of picture where that would be if we added those together. We just found this vector, yeah? So the length of that vector is about 53, and we're going to now be looking for the angle of that vector. Just a reminder, if we know the x and the y value of a vector, we can find the angle of the vector using tangent, right? Because tangent would be its y value over its x value. So if we were finding the direction, we're going to wind up being able to do the inverse tangent of the y value of the vector over the x value. Opposite over adjacent is tangent. Inverse tangent will give us that angle. I'm using some nice calculator stored numbers here, so if you're getting different numbers, it could be a rounding issue. I guess we're going to the nearest whole number here, so that's coming out to 41 degrees for me. So another testament to the fact that that angle, that original 60-degree angle, is not bisected. This was a 41-degree angle, so it veered a little more towards the 40 vector, the vector v, because that was a bigger force. I guess not force, it could be a speed or an acceleration or whatever. Shall we try another one? Maybe you guys want to try this one without me. Maybe I'll just kind of work on it and you should work on it, and you guys can look up every once in a while and see if you're getting the same answers as me. Does that sound like a deal? So vector u, vector v. See how far you can get. All right. I wish you were here to tell me if I made any mistakes. I had some trouble with my calculator, so hopefully you caught up with me at some point. Or maybe you passed me like crazy. But there's the answers I got. Officially, that last angle was 38.642 degrees, but to the nearest whole number for whatever reason. Yeah. So all of these are just kind of the same idea, right? This one we get to draw ourselves. That seems fun. Vector u has a magnitude of 24 and a direction of 0 degrees. Okay, we love it when it's a 0 degree because that means we get to point it straight to the right with a length of 24. And then vector v, oh, that was u. And then vector v has a direction of 115. And that one has a bigger magnitude of 40. That's going to be our vector v. And we're just going to do the same thing, right? Hopefully these get easier as we go. So if you want to go again, we'll see. Do you think you could do one of these on your own now? That's what we're shooting for. See how far you can get. If you just want to play SOHCAHTOA to find your X and Y, you totally can do that. What would this be, a 65-degree reference angle? The only thing you'd have to watch out for then is to make sure that you call that X value a negative X value at the end, right? So we could still play it that way. Remember, 40 is the hypotenuse. If you use the 1 to 15, it would remind you that that's a negative 16.905. If you're using the 65 degrees, you have to remember the negative. Okay. Can you picture why it would be that vector this time? Parallelogram method. That's my favorite. So we'll be going a little to the right and up to that 36, but only a little to the right, over to 7. Okay, and then just magnitude and direction of that number, or of that vector, so go ahead. All right, there's my answers. All right, so these are official word problems, but really they're no different than the ones we just did. It does say to draw the vector, so one of the forces is applied in the direction of the positive x-axis. That just means we're going to be smart about it, and maybe our first vector, we'll always make sure that goes straight to the right, just so one of our vectors is easy to make into component form. 2 forces with magnitudes of 20 pounds. Let's make that go to the right. And 14 pounds at an angle of 55 degrees. Are applied to an object. So maybe there's 2 ropes pulling on an object. One's pulling in one direction, one's pulling in another. One's pulling harder than the other. Where does the object slide? Find the magnitude of the resultant vector to the nearest whole number. So I guess we're not going to really talk much about where it slides, but at what poundage it slides, at what force it slides. So let's go for it. We're just going to need to write the component form of both vectors. This one's easy. This one is getting easier, hopefully. Are you getting into the swing of this? But the x one is always going to have to do with cosine, right? Sine is the y value, so sine always has to do with the y over the hypotenuse, which was 14. Add those together and we'll find the resultant. And this time they just wanted the magnitude, so go ahead and find the magnitude of that. And I'm getting about 28. And it's always in the same label that we used before, so that's 28 pounds of force. Hopefully these feel easier as you keep doing each one. Another 2 forces. All right, this one's supposed to be a challenge one. Let's see if it can challenge us. They're getting too easy, aren't they? 2 forces with magnitudes of 200 and 340 are applied to an object. The magnitude of the resultant is 150. How did the resultant get smaller? It must have been that these two are sort of counteracting each other. So the way I'm going to draw this is I'm going to draw the 200 pointing this way. Not that my drawing has to be good, but just so I can kind of get a feel for it. Maybe the 340 was pointing this way. And that way, when they combine together, the resultant vector would have gotten shorter. You know what I mean? And so then it would only be 150 long. That's just how I'm picturing it turned out. It says, find the measurement of the angle between the resultant vector and the vector of the 200-pound force. So we are supposed to figure out this angle in the end. We shall do that. I kind of drew it looking like a 90-degree angle, but who the heck knows? We'll figure it out. All right. What do we know? What do we know? Oh, well, this is a parallelogram that I just made, yeah? That means that this is also a 200 and this is also a 340. I'm totally looking at this triangle right here. Do you see that, boy? This triangle right here. Do you see that law of cosines just begging for that theta to be solved? I've got the 340 across from my theta. I think I'm going to law of cosines that. Are you seeing it? That should work, yeah? Let's do it. So we'll subtract the 62.5 over. Divide the negative 60,000. Take an inverse cosine. All right, it was 152.25 degrees, so my picture wasn't great. I think that 340 must have been leaning over quite a ways more than I made it draw, but whatever, I'm gonna trust the math. Hopefully that cleared up a little something for you. We will come back at it tomorrow. Thanks for playing.